Good afternoon, everyone. So before we begin, please confirm me that you can hear me and see the slides clearly by just typing yes in the chat window. Also, we would like you to introduce yourself, your name, your designation, the company you belong to, and your country. It's a pleasure to see an international audience of people from all industries and backgrounds. Good to see you all, and great. We are receiving your confirmations. Thank you. I would like to thank you all for registering and taking time out on a Sunday to learn about how to execute quantitative risk assessment QRA studies. Learn with example the case study, the topic of today. My name is Aisha Khalik and I will be your introductory speaker for today. It's our pleasure to host this webinar for you. Just for your information, this is our 88th webinar in a series of technical webinars that we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn, YouTube, and make sure to check our website also for the latest update. Today, we have an experienced panel of speakers. I am with my colleague, Mr. Ijazul Karim Rao, Managing Director, Principal Integrity and Safety Consultant. Madam Mubina Khatun, she's Director, Engineering Services. Mr. Anthony James William, he is General Manager of Global Sales at Velosi. So moving forward during this webinar, we encourage you to keep asking questions to clear any doubts. We would definitely like your engagement on this topic. You can type your queries in question and answer window and you will receive a reply in the question and answer window, or we can take your question live and answer it. As we have a detailed question and answer session after the completion of the topic, please accept our apologies if your question is not addressed. As we receive a high volume of questions every weekend, we have to be selective. Furthermore, we will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the discussion through question and answer. Since this is a quite technical subject, we will touch only the key aspects and practical aspects of how to execute quantitative risk assessment, QRA, and see it with studies and learn it with the example of case study. In this limited time of 2 hours, we request you all to follow along with us and keep asking questions so that the session becomes as engaging as possible. Before we begin, let's have a safety moment. Although most of us are in the comfort zone of our homes, we should be aware of emergency exits. We should keep a safe distance and generally take care of ourselves and those who are around us. Now, I will invite Mr. Ijazul Karim Rao to start with today's topic. Thank you.
Assalamu alaikum and good day, everyone. Today's topic is QRA, which is Quantitative Risk Assessment. And we start with the definition, like what is risk analysis, first of all. So if we say, what is risk analysis? So in a general term, we always make a decision while going out, while crossing the road, like if we are crossing the road, is it safe to cross the road? What is the probability of vehicle or a motorcycle or any other moving object may hit you? Probability is there, and consequence is very, very severe because it can result in fatality or serious injury. So it means that we always know that up to a certain extent, what is a risk definition. For example, if I am or we are trying to invest money in any investment company, so there is a danger we may lose overall investment, or there is a potential probability on the positive side we may make profit. So risk and opportunity, two things go side by side, or we may also say risk and reward also goes side by side. So if we are talking about general risk, so we understand what does risk mean. Risk means either opportunity or a risk. Means what? Either we can lose certain things or we can gain certain things. Sometimes it is said that if we will take certain chance or certain sort of risk, then there could be some chance of reward as well. So coming back to the book definition, the risk analysis is the process of identifying and assessing possible concerns that might have a negative influence on major business efforts or project. This procedure is carried out in order to assist business in avoiding or mitigating hazards. It is a process of prioritizing risk based on the probability of the risk occurring and the impact it would have on the project. So now, as I said earlier, risk analysis could be judgmental based or it could be based on the calculations. So on the same ground, we can do risk assessment practically in three methods, not two methods. One is the qualitative risk assessment method. Second is full quantitative risk analysis method. And third one is semi-quantitative, mean partly qualitative and partly quantitative. So these three risk assessment methods are prevailing, and either one can be used or combination of three can be used for any risk analysis exercise. Now, what about the history of the risk assessment? It is as per the trend in the books or on the media, during 1950s, used an alternative to market insurance. Risk was used an alternative to insurance market. For example, due to wars, the many insurance companies, either they increased the premium too high or they were not covering all the risks which are associated or the consequences which were associated with any damage. So at that time, the company started using the risk assessment criteria. In 1970 to 80s, the company started using derivative as a risk management instrument as the companies improved their financial risk management. Then this current system of risk assessment and risk management started in 1980s basically, and now it's being used almost in all segment of the life. So what is the benefit of risk analysis? So benefit of risk analysis mean risk, when we say, keep in mind, it is not only a negative side of the hazard, but there could also be an opportunity. For example, if we make investment somewhere in the right direction, then we, in a business, then the business grows, we can make more profit. And what is the probability the business will succeed? We will get the right number of audiences or the clients, and our scale will grow in a way we will be able to make profit. So that is also some sort of positive outcome of the risk analysis. But if something goes wrong, then what kind of consequences in terms of fire, in terms of money loss, in terms of asset loss can take place? So that could also be a tool to assess the outcome of our decision-making process. So in a way, recognize and control hazards in the workplace, then create awareness among employees, establish risk management guidelines based on accepted safety procedures and regulatory requirements, and risk assessment process detect, assess, and compare the total financial and organizational effects of risks to the organization. Then decide the next action to eliminate security flaws and enhance security, identify security gaps, and determine the next steps to eliminate the security flaws. There are many benefits we are debating in the beginning. So as we have a fair idea about the risk analysis process. Now, what are the general steps when we make risk analysis process? First of all, we need to identify the hazard, and then we do the risk assessment. Then analyze the risks, develop a risk management plan, implement the risk management plan, then monitor the risk management plan which has been applied, like all the mitigative measures or all the preventive measures which we have identified, we are taking, whether taking care or whether those are effective and minimizing the hazards on the workplace. As a normal definition, how we do risk assessment, first of all, system definition or system boundary, what kind or where we want to do the basically risk assessment. For example, as we said, if we are crossing the road, there is also some sort of risk assessment. If we are making any investment in any bank or any other insurance company or our own business, we do assess what is the risk we will be able to make the money. Similarly, in process side, if we are making a hydrocarbon facility, what is the probability where ignition can take place and it can burn the entire facility? So there is also risk concept. So in a way, what do we do? First of all, we define where we are doing the risk assessment. Then hazard identification is done. Then consequences in terms of dollars or in terms of asset loss or in terms of fatality is calculated. Then likelihood, and then risk is basically estimated with a multiple of likelihood and consequences. Let's take one example like how we apply a risk assessment concept in our day-to-day life. For example, like in any organization, insurance company, if they are trying to insure, let's say 1,000 cars in 1 year time, and where they're charging only 1,500 USD per car as an annual premium. And whereas let's assume the total cost of each car is 15,000 USD. So they're taking only 10% of the cost as a premium. Means if one car will face accident, the insurance company will end up paying the full 15,000 money. So let's see how much money the insurance company is able to collect if they're insuring 1,000 cars. So 1,000 into 1,500 is about 1.5 million. So let's say 50 cars out of 1,000 cars are meeting accidents and they're fully damaged. So, and in a way, so how much, what the probability of the car being hit by accident is a 50 divided by 1,000 is 0.05 per year occurrence. Then price of each car USD is 15,000. The total risk for the company 50 by 15,000 is 750. The margin between the investment, like money being collected and the potential they would be ending up paying the money to the customer is 750 versus 1.5 million. So almost 100% margin they got. If something still goes wrong, like if there is a more rain or more accidents and due to weather or some other reasons, then the insurance company may end up making losses. Otherwise, they would be making the profit. So this is the one quantification of the risk in our mind if we want to understand what does mean by a risk calculation. So this risk calculation is in a simple terms one can use for understanding. Now, there are like two risk assessment tools, qualitative and quantitative. Qualitative risk assessment normally we call judgmental based, and quantitative risk assessment we call calculation based. So in qualitative, for example, in both risk analysis tools, risk matrix 5 by 5 or 3 by 3 or 8 by 8 or 6 by 6 risk matrix can be used. And the result can be presented in the same kind of risk matrix. However, the first one, qualitative one, is judgmental based, where the opinion, like people, 4 or 5 people sitting in a room and saying that what is the probability the hydrocarbon will leak from this place. They will say probability is 1, 2, 3, 4, 5, or they may say 10 raised to power minus 2, 10 raised to power minus 1, or one may say 1 out of 100, 1 out of 10, 1 out of 10, 20. So the numbers could be any. And then consequence wise, what will happen if this will fail or leak, then there could be a number. And then by multiplying both, we can have a risk matrix position. Same as it could be applied on any business point of view. But in quantitative risk assessment, there would be a certain calculation on the number of, like, take the example of RBI, risk-based inspection program, where we say, okay, what are the damage mechanisms? What is the corrosion rate? Then what is the remnant life? What is the damage factor? So the quantitative risk assessment can be done similarly in terms of consequences. What would be the effect on the production, on the people, on the environment, and then its quantification is done. And with that quantification, the risk assessment is done. That's got quantitative. But if opinion based only, then it would be called as qualitative. So in a normal terms, qualitative more opinionated, quantitative mean mostly on the calculation based. And then there is also a third term, which is called semi-quantitative, where some opinionated and some based on the calculations. So the results point of view, the quantitative could be considered as a more like a relative to accuracy, and qualitative would be more opinion based. There would be more estimation margin is there. So semi-quantitative is in between accurate and semi-accurate, right? Now, when we say qualitative risk assessment techniques point of view, so there are various qualitative risk assessment techniques, even in RBI, risk-based inspection program, we always talk about there are three kinds of RBI: qualitative RBI, semi-quantitative RBI, and quantitative RBI. It is also driven by the risk assessment definition, like qualitative risk assessment, semi-quantitative risk assessment, and quantitative risk assessment. Now, there are various techniques which are used to carry out qualitative risk assessment, basically process. Under qualitative risk assessment aspect, the qualitative risk assessment technique include, for example, hazard assessment or OHID assessment or INVAD assessment. There are three workshops which are done for assessment of risk hazards which are related to safety, is termed as hazard. The term which is related to environment, we call it INVAD. And the third one is related to health, which is called OHID. So three workshops are done: occupational health related hazards, environmental related hazards, and safety related hazards. And once we have a hazard analysis done, then we know that these are the minor hazards or major hazards or accidental hazards, major accidental hazards, MAH. Then we try to reflect them in the bow tie. Under bow tie, we try to graphically show all the probability side and consequence side, the layer of protections and escalation factors. Then there is also FMECA, which could be a technique like qualitative, and sometimes we can also make it semi-quantitative. Then safety cases, where basically based on the hazard and the bow tie assessment results, we can identify which are safety critical equipment and systems within the system. Those can be identified. Then quantitative risk assessment is more like, as I said earlier, quantitative calculation based, right? And where probabilities also, some calculations are involved, consequences side calculations are involved, and multiple the mitigation layers are also involved in the calculations. And in this way, we try to demonstrate the risk aspects or the consequence aspects on the system. For example, if we take quantitative risk assessment, normally we use two softwares. I'm not like favoring DNV, but since we are using mostly DNV, and that's why I'm referring them. So two software we normally use for the QRA. One is the FAST, and second one is SFATI. FAST is basically for the dispersion modeling, which is mostly consequences, and SFATI is basically risk, consequence and probability, and then risk is being calculated. So by combination of these two tools, where SFATI is a combination of FAST and like the risk side, so then we are able to see the contours of the consequences side and contours of the risk as well. So in general terms, the data which is populated is based on certain calculation, certain input data, and then accordingly, we are able to estimate risk up to particular like accuracy level. We cannot say the QRA risk assessment is very accurate. No, it's still a judgment, like many ifs, and there are many assumptions are there. For example, who can say whether hole size would be 1/4 inch, 1 inch, or there would be a rupture? Which part of the pipe would have a leakage? Nobody can guess, but still we try to make certain best estimate, best guess, and then we try to do the calculation based on the inventory and based on the size of the equipment and the composition of the fluid, and so on and so on. So in a way, there is some accuracy, and still there are certain assumptions which are being used under QRA as well. So two studies which are very much relevant to quantitative risk assessment. One is QRA, and another one is a FERA. The first one and the last one in my presentation, this one and the last one. Here, QRA is quantitative risk assessment, and FERA is a fire and explosion risk assessment. Both are more or less same. The FERA is more focused on the assets, whereas the QRA is more focused on the people. Then ESA is there, emergency system survivability assessment, and ERA is evacuation, escape, and rescue analysis. So if we try to see a question to ourselves, what can you deduce from the different deliverable of qualitative and quantitative assessment? So in a way, if we see that, like what we can produce, what we can achieve. So here, both type of risk assessments are necessary for risk studies and they do not go against each other. One is like a qualitative, semi-quantitative, and quantitative. So the qualitative, all three type of risk assessment approaches basically complement each other. One is more on the quality, like a judgmental side. Other one is judgmental plus calculations, and the quantitative is more on the calculation based. Then quantitative assessment form the foundation for quantitative, like qualitative assessment form the foundation of quantitative studies that need to be performed. Both type of risk assessment are equally important. For example, bow tie analysis is a qualitative study. It provides input for many QRA studies. Now, if we try to go a little bit more on the quantitative risk assessment side, so what is QRA? Like now, there you will see some sort of like a repetition. We are debating the same points again and again. But point is this webinar is focused on the newcomers. And I know that like there could be some people who already knew about QRA process. For them, it could be a little bit boring or repetitive one. However, for newcomers, I have to go through the basics. So as people can understand, they can use it further. So QRA stands for a quantitative risk assessment. It is a technique for the evaluation and integration of hazard frequency and consequences to drive a numerical estimate of risk associated with the operation of an engineering process. It could also be applied on the non-engineering, but we are saying engineering process. Current process engineering projects are increasing in size, both in terms of capacity and footprint, and this inadvertently increase the risk and consequences of the accidents. Now, the type of the hazards, there could be process hazards, environmental hazards, and occupational hazards. When we get occupational safety hazards, like normally we call it H, S, and E. E is a health, S is safety, and E is environment. Process hazard goes with S, occupational hazard goes with H, and E goes with environmental hazards. So which hazards are considered for QRA? Normally, process hazards. Process hazards. Now, the quantitative study of accident results in many consequences such as fatalities, injuries, pollution, loss of revenue, and loss of reputation. But here, like in the ORQRA, mainly it would be focusing on the PLL or the safety hazards generally. It is an industry recognized technique used to better understand the risk and the consequences of accident for an asset. The term QRA, which is quantitative risk assessment, is used synonymously in different industries to describe various techniques for evaluating risk. Then, now, what is QRA? Like again, technique discussion is ongoing. High risk or major accidental hazards have been identified for operation. QRA shall be required to demonstrate tolerability and alarm in support of a project or a facility. There is potentially high risk exposure to worker or the public at project site. See, what we are trying to do in the trying to achieve in the QRA is like what are the hazards, what the quantity of those hazards, quantification wise, how big, how small, how much effect this hazard would have on the people, on the asset, or in terms of toxicity impacts, or in terms of fire and explosion impacts. And then accordingly, what kind of preventive measures are there, what kind of mitigating measures we can add and we can utilize in the basically minimizing those hazards for the owner and for the operator in the area. Application. So identify process hazard associated with the facility. Number one, as we've been discussing again, it is a valuable tool for determining the risk of the use, handling, transport, and storage of the dangerous substances. The quantity to quantify the risk associated with the facility, for example, risk contours, individual risk per annum IRPA, potential loss of like PLL and FNF plots for the various kind of risk it can demonstrate. Identify appropriate risk reduction options. Development to demonstrate the risk are being managed to a level is a low as reasonably practicable. like alarm region. So we cannot, like in any operating facility, we cannot have a risk up to 0. It would be always there. Some risk is always there. And it means that we need to operate the facilities in the alarm region, I mean, as low as reasonably practicable. For example, we cannot stop going out to on the roads, and either we are driving or crossing the signal. So we have to take certain precautionary measures, and then we have to make our journey, and we cannot sit in isolation always. It means there is a risk for the life always. Similarly, in hydrocarbon facilities, there are hydrocarbons, and there is a oxygen in the air. Only one thing which is missing, that is the ignition source. So to minimize the potential of fire, we have to control the ignition source or the leakage of the hydrocarbons from the confined spaces. So in a way, to manage that part, we have to take certain risk, and to having that certain risk, we are still making multiple investments, multiple facilities are operating in the world, and those are being operated, and risk is being taken and managed by the owners and by the operators. Next, like when we say like if there is a certain risk associated, so how that risk can be minimized. So to minimize the risk, we may have to increase the costs. We may have to add more mitigative measures. We may have to make like a more safer or inherently safe design of the process equipments. So it would also have a certain cost. So there is a cost benefit analysis, like how much risk we have to take and how much cost we have to do. So there's based on the cost benefit analysis, the system or operation is kept inside the alarm region. So some other QRA applications, such as fatality risk assessment, comprehensive QRA, risk to life, safety function, etc., evacuation, escape and rescue analysis, I said earlier, emergency system survivability assessment, ESA, fire and explosion risk assessment, that is also part of the QRA or risk assessment exercise. Benefit we also covered earlier, but again, to make you people carry forward, like what the benefit of QRA, help to reduce risk by supporting risk-based decision-making, comparing options during the design phase or for modification during the operations, supporting the demonstration that risk levels are reduced as low as reasonably practicable, defining requirement for land use planning, defining requirement for emergency response planning. Then there is also a limitation for the QRA process, implies a level of accuracy that does not exist. Like it's not so accurate. There are certain like how we estimate the volume of the fluid, how we estimate the parts of that particular inventory, how we make the inventory isolatable sections, and similarly the number of holes, the location of the hole, and direction, wind effects, and so and so. So there are like still other factors which create some sort of limitation for the QRA process, can divert attention from precautionary or preventive measures. Lack of reliable data in specific areas may also cause trouble and may misdirect our direction, often dominated by hardware issues and rigid handling of the human factors. Theoretical modeling may not reflect actual operations. So there are the limitations the QRA, but something is better than nothing, and it can give at least a brainstorming process where we are thinking about the hazards, we are talking about how big is the hazard, then we are also talking about the number of mitigative measures, or we are trying to demonstrate all the barriers in a bow tie. And so by this process, it is always helpful, but with having all those positivities, there are certain limitations which should be kept in mind as well. Then general QRA objectives, like what we will be covering. As you can see, like a lot of theory, like why QRA is required. So we're just going through to understand what are the weakness, strength, weakness, and what is the objective, what we want to achieve out of QRA. There's the first objective. But then we'll also be passing through the process of the QRA, the estimating or quantification of the risk associated with the hazardous process. It can be like helpful, right? Like we can estimate like what is the volume of the risk or a hazard which is associated with the facility, identifying the main risk contributor to overall risk, which help to understand the nature of hazard and suggest possible action for reducing the risk to a tolerable or alarm region with analyzing their effectiveness. Then evaluating risk reduction measures, QRA can be linked to a cost-benefit analysis to help choose the most cost-effective ways of reducing the risk. Then demonstrating compliance with regulatory risk tolerable criteria are showing whether the risks have been made as low as reasonably practicable. Identifying safety critical procedures and equipment, these are critical for minimizing risk and need close attention during operation. Highlighting the attention to workforce with accident precursors which may be monitored during the operation. Increasing awareness of hazards, scenario-based escalation and mitigations. Now, why QRA important? Like one incident, which we are just showing you, it was in 2009, Catano oil refinery in basically it was in South America. Caused malfunctioning tank fuel gauge. Workers failed to notice one of the tank was overflowing before the fuel vapor ignited upon contact with electrical equipment. Consequences: no death, 3 non-fatal injuries, several buildings and oil tanks damaged, 30 million gallons of petroleum was released into bodies of water and neighboring wetlands. So this is the picture you can see. So these are the real scenarios where fire can occur and it can destroy the entire facilities and it also can kill people. To avoid these kind of scenarios, it's better to make real hazard analysis and the required mitigative measures to be in place. Standard references, if I have to go through, like here, the first reference, Risk Assessment Data Directory Overview, which is OGP 434, right? So this is the Risk Assessment Data Directory. This is one of the document which can be used for reference. Second one is a SAFETI 7.2 training. Now it's a further latest update is there. My presentation is old one. Previously it was DNV GL, now DNV only. GL has been removed. So the software, like you might be using some other software, so you may need to have the user guide for that software as well. Similarly, there's a TNO book, which is normally called PGS2 yellow book, method for calculating physical effects. So this TNO book, what it calculates, if I can show you, like here, general introduction, outflow and spray release. There is a pool evaporation, there's a vapor cloud, dispersion, there's a vapor cloud explosion, heat flux from fire, then rupture of vessels, and so on. So these guidelines are basically applicable for our QRA process. So we should have the relevant references so as we can read what are the major calculation modes and theoretical models applicable on the QRA process. Similarly, if we go next one is a PGS3. I would ask the participants, please add your questions in the question answer windows, and we will be taking the break and we will be answering those questions. So in between, if you have any question, please keep writing. You have to take one question answer break in the middle almost. After 10 minutes it would be, and then we'll go to the case study. So just for your attention, please take note and we'll be answering some of the questions. So next, if we say yellow book, purple book, and TNO book. So there are references, international references, which are available for us to work on the QRA modeling. So here, purple book, guidance for quantitative risk assessment. And if we see certain elements here, so selection of the installation for the QRA, then loss of containment is there, then modeling, source term, so the source term and the dispersions, then next modeling, exposure and damage, then calculation and presentation of the results, and so and so. The quantitative nomenclature is also there. So in a way, what I'm saying here, there are various references. the reference what we are showing are the minimum one, and there are other references can also be taken from the other international sources. Next one is like there is also ADNOC references like ADNOC HSC risk management. There is a standard ST01, and this standard also covers like one thing I should acknowledge that we are working in the entire region, like in UAE, in Saudi Arabia, in Qatar, in Oman, and other like in Far East and African region. ADNOC HSC management system is one of the best in overview. We are not saying like as a like a biased point of view because we are in Abu Dhabi, but what we have seen. So ADNOC has described HSC MS system in a very effective way, and it's a regulatory requirement for every project, and all the required studies and the demonstration of the risks are required to be managed in a documented way, and everything is every project at feed stage, at EPC stage, and operation stage is basically all HSCIA related documentation and protocol is required to be reviewed and approved by the ADNOC HQ. So this is one of the standard where ADNOC is like using it for its projects. For example, if you see it, risk assessment and management system, then 7.2 is hazard identification and risk screening tool is there, then regulatory criteria is there, 7.6 risk reduction measures and alarm demonstration is there, and so and so. So ADNOC has basically published all the relevant standards for the HSCIA protocol basically. Then there is a HSC RM ST10, ST10 means ST10, which is quantitative risk assessment, and this is a QRA standard we call it. So it also carries like all aspects like hazard identification, for example. Then if you see next, hazard identification, receptors, frequency assessment, consequence assessment, impact assessment, non-process risk assessment, escape, evacuation risk assessment. Everything is okay? Okay, right. Integrated risk assessment, H2S zoning, then building risk assessment, integrated QRA, sensitive analysis, and so on and so. So if anyone wish to learn more about how the QRA can be done, the ADNOC has established like a very useful documentation and code and practices as well. Then QRA applications, if I go next. Here, what are the QRA application are used? Life cycle asset risk management, land use planning, decision support, equipment design support. It can also help on the quantify the benefit of mitigation measure like fire and gas detection system, passive fire protection system, what kind of layout and location of the utility buildings, then detailed cost benefit analysis, safety case development, operational risk management, escalation assessment, layout optimization, then compliance and legal requirements, insurance related actions. So there are various use are there for the QRA study if we want to make effective use of QRA process. QRA study deliverable generally the QRA methodology and assumption register, isolatable section marking on available latest PNIDs, parts count and failure frequency calculation as per OGP database, static and dynamic inventory calculation of failure case scenario, process chemical composition and properties, consequences modeling results, ignition probabilities, risk model as per Yokoa lookup correlation model, risk reduction measure, alarm demonstration. So then basic data, what we need for QRA study is as like a complete process description of the process of facilities to limit QRA scope and boundary, post HAZOP or latest piping and instrumentation diagrams, process flow diagrams, plot plans, then heat and material balance sheet, HMB sheet we call it, Manning distribution philosophy, risk tolerability criteria requirement, then applicable codes and standards. So before we go to the QRA case study, we'll take the question answers now. And Ms. Adeline and Mr. Ali Ahmed would be assisting me.
So, sir, the question is from Mr. Bela Khadar Ayub. We have allowed you to speak. Kindly ask your question, please. Mr. Bela Khadar.
So I can read that question. Is there any specific standard to develop a quantitative risk assessment matrix? See, quantitative risk matrix, basically it is driven by the company risk matrix, which is like a 5x5, 6x6. So ADNOC does have its risk matrix, which is 6x6. And similarly, other companies are having their own risk matrix. And then IRPA criteria or the risk acceptance criteria is also defined for the by like yellow book, purple book, and this TNO books. And those books can also be used as a reference for the basic risk matrix. Next question.
So, good morning, sir. I would like to ask you what is the differences between quantitative risk assessment and quantitative risk analysis?
See, as I explained earlier, qualitative risk assessment is mostly based on the judgments. If the 4 or 5 member team is sitting, right, and they make like what the probability of this happening and what the consequences, that is called normally qualitative. But if the calculations would be involved, like how much is the inventory, what is the composition of the fluid, then what is the, like if the some leak happening, what the size of that hole would be, whether 1/4 inch, 1 inch, or a rupture, and then what would be the dispersion of the fluid, what is the probability of the fire, and what are the explosion chances, and so on. So all those calculations which are made by use of some Excel spreadsheet or by a proper software, that's called normally quantitative. Whereas if we do a risk assessment by HAZOP, for example, or hazard workshop, where opinionated based discussion is taking place from various professionals and or engineers, and those are doing the risk assessment, that is called normally qualitative. And there is also, as I said earlier, semi-quantitative as well, like which is in between judgmental and calculation. Some calculation, some judgmental, that is called semi-quantitative risk assessment. Okay, sir. Go to the next question, please.
Sir, next question is from Mr. Motaz Al-Murshidi. We have allowed you to speak. Kindly ask your question. Mr. Motaz Al-Murshidi.
So I can read the question. Motaz is asking basically if there is any relationship between damage mechanism of API 571. So see, QRA is mainly for quantitative risk assessment, whereas API 571 is more part of risk RBI techniques, which is called quantitative RBI technique. So for 571 damages, which are assessed under RBI technique, in RBI also, there is a risk assessment process, but more focus in RBI is on the damage mechanism and probability of failure, whereas in QRA, more focus is on the consequences of failure, whereas probability of failure is on the simplest calculations. So the 571 based damage mechanisms are more relevant to quantitative or semi-quantitative or qualitative RBI. And in general, we don't use API 571 based damage mechanisms in QRA studies. Thank you. Next question, please.
Next question is from Mr. Deepak Pal. We have allowed you to speak. Kindly ask your question. Mr. Deepak Pal, please ask your question.
I can read the question. Please elaborate a link between bow tie and QRA. In bow tie, we try to basically demonstrate all hazards in a graphical way, where the probability side and consequence side, escalation and controls, and also mitigation and controls, both are shown in a graphical way. And in QRA, basically the detailed calculation of the consequence analysis and dispersion and contours are shown. So basically, bow tie is a way to demonstrate your hazard in a graphical way, whereas QRA, we try to quantify those hazards by the calculations and by the support of fast and safety software or some other software which are equivalent to these softwares. Next question, please.
So next question is from Mr. Ghaus Muhammad. We have allowed you to speak. Kindly ask your question. Mr. Ghaus Muhammad.
So I can read. QRA is a quantitative risk assessment, which is done by the use of any software, like, as I said, FAST or Safety, or there's other softwares as well. Whereas HAZOP is a qualitative technique with a hazard of probability analysis, where node by node and by using proper some guide words like a low flow, no flow, high pressure, low pressure, or like a temperature high, low, or level high, low, or vibration high, low, or some other guide words. We try to assess what are the present safeguards and what may go wrong if the safeguard does not work, what are the consequences of the failure, and then if the current safeguards are enough or we need to give new recommendations. So one risk assessment with the current safeguard and then recommendation and the new risk assessment. So in this way, recommendations are made by the team of engineers where workshop is handling in the presence of one third party or independent chairman, and all participants are basically giving their views, process side, instrumentation side, operation side, and mechanical or corrosion. Then accordingly, the plant probability review is being done. That is called HAZOP, whereas QRA is done quantitative risk assessment, mainly on the quantification of the hazards in terms of basically leakage of the fluids, and then dispersion, then fire and explosion, and so on. So QRA is a different technique as compared to HAZOP. HAZOP is applied on P&ID nodes, whereas QRA is applied also on the P&IDs, but on isolatable sections in terms of quantification of the, like if a fluid leaks or it go out of vessel or pipe, then what is the probability of the fire, and then what would be the size of that fire, and how that fire can be controlled or mitigated. Thank you. Next question.
So next question is from Muhammad Usman Asghar. We have allowed you to speak. Kindly ask your question. Mr. Muhammad Usman Asghar.
Yeah, good afternoon, sir. The question is about what is the right time, for example, in life of the project to do QRA? And is this like evergreening that you need to update after some time? And what are the prerequisites like drawings? What are the drawings required to do this QRA? Thank you.
Thank you. The QRA can be done on at any stage of the life cycle of the project. Feed stage, it is done. At EPC stage is also repeated. Then at operational stage is also repeated or done first time. So QRA can be done at any stage of the project. Understood? Secondly, the document what you need for the QRA is the PFDs and heat and material balance, P&IDs, equipment layout drawings, and the circumstances or the neighboring facilities of the plant. So those are the documents what you need for QRA, and QRA can be done at any time. Thank you.
Sir, next question is from Mr. Naveed Ahmed. We have allowed you to speak. Kindly ask your question. Mr. Naveed Ahmed.
So I can read that using aloha for the ammonia release or fire spread would be type of QRA or FERA. QRA and FERA are more or less same because the focus of the QRA is on the people and focus of FERA is on the asset. That's the only difference. And ammonia is not so combustible in general terms. It's more like a toxic and lighter than air. So the issues related to ammonia is more towards the toxic hazards which can affect the people, especially in the confined space or like covered areas or the shaded areas, whereas normally the QRA focus on the hydrocarbons is more on the flame and explosion. Ammonia, flame and explosion are on the limited scenario, lesser scenarios because of the nature of the ammonia is NH3. It does not carry carbon atom. So the chances of oxidation of ammonia are remote or lesser. So this is what my view is. However, QRA can be done or FERA can be done for ammonia. And in both scenarios, the objective is like one is the people, other is the asset. But QRA and FERA both are done by using, as we are used to use by DNV's SWETI software.
So next question is from Mr. Marcus Michael. We have allowed you to speak. Kindly ask your question. Mr. Marcus Michael.
So here the question is the risk ranked on the raw risk or on the mitigated risk? Basically in the QRA, we rank the risk as a mitigated risk because all the mitigative layers like the fire and gas detection system, firefighting system, passive fire protection system, or inherent safe design or hazard area classifications and so on. So those are considered while reflecting the actual results as a result of QRA analysis in the contours. So if no questions, we can go next. More questions are there. Okay, a few more questions we can take, then we can take the question at the end.
Sir, next question is from Mr. Babul Chandra. We have allowed you to speak. Kindly ask your question. Mr. Babul Chandra.
Like here, I can read, what are the risk tolerance criteria? For example, risk tolerance criteria is up to what extent we can accept the risk. For example, if we go next, I will show you like in a LARP diagram. For example, 10 raised to the power minus 5, 10 raised to the power minus 4, 10 raised to the power minus 3, or occurrence wise, one in like a 10 years time, one in 100 years time, one in a million years time. What is the acceptance like that occurrence may take place, and that is tolerable. So in a way, acceptance criteria of any risk is shown in terms of like, as I said, 10 raised to the power minus 5 means 1 out of 100,000 years, and then minus 4 is a 10,000 years once, and 10 raised to the power minus 3, which is out of 1,000 years or occurrences. So that is the kind of scenario. So the risk acceptable criteria or tolerance criteria is defined in the regulatory basically standards, and that we need to follow. So let's go back to the presentation, and we'll come back at the end of the presentation one more time, and we'll have a question answer session at the last one more time. So the QRA case study, and now what I will be presenting is LPG based SNG plant, synthetic natural gas plant, and we have basically carried out QRA, and we have selected the simplest one so as the participants can understand it. So the objective of this QRA study for LPG based SNG plant are as follows: determine the characteristic of potential fire, dispersion, and explosion event, along with its potential for escalation, with focus on major accident event. Assess the potential consequences in terms of impact on people, critical operating systems, and vulnerable infrastructure, including on-site equipment and public facilities or roads. Then evaluate the effectiveness of the hazard mitigation measures and identify any risk reduction opportunities to verify the intended design, ensure the potential MAE risk are as low as reasonably practicable alarm. Then process description, SNG plant, which is synthetic natural gas plant, to be installed at a client site in design to supply gas to total of 306 residential villas. Consumption is about 5,084,008,861 BTU per hour through a dedicated natural gas network carefully designed as per client standards and regulation. The equipment of the mentioned SNG plants are as follows: 2 underground LPG storage tanks with a capacity 10,000 liter each, pumps kit consisting of 2 pumps with an overall capacity of 200 liter per minute, an SNG model XPV 13-10 with capacity up to 13 mm BTU per hour, inlet pressure like 4 to 8 bars, outlet pressure 700 millibars, solenoid valve assembly and filtration station, and filling line. So this is the facility. If you can see on the drawing, there are 2 underground LPG vessels, and these are the pumps. And this is basically a tanker which is bringing LPG now and then to fill these vessels. It's the simplest facility, and plant location, if you see among the residential villas, these all are the villas where the gas has to be supplied, and the plant is located here. QRA methodology, what we used: hazard identification, then scenario identification, then frequency analysis, consequence modeling, risk determination, then evaluation of the risk, then identify and prioritize potential risk reduction measures. Here, like we did hazard workshop, and under that hazard workshop, 09 high risk hazards, 21 medium risk hazards, and 03 low risk hazards were identified. So this was the sample worksheet what we used for the hazard identification or hazard identification node by node. Here if I try to show you what we try to cover under this, for example, guide words, threat, top event, consequences, potential risk, like with the current safeguards, and then recommendations. If we have to add, then it would be the new residual risk after the recommendations. Next, like we identified isolatable sections. The isolatable sections are marked on the latest PNIDs, and these isolatable sections are marked with the help of our identification of emergency shutdown valves, emergency depressurization valves, then remotely operated valves, then normally lock-closed valves. Here, in this scenario, a total of 5 isolatable sections were identified in the current project. It was a small project we are just showing you. There are many complicated projects, but this is the simplest one. Here, these are the 5 isolatable sections. Number 1, a A100 filling point where the tanker is coming and pouring the LPG. Then storage tank filling line. Then equalizing valve, return line. Then B200A gas storage tank. Then B200B gas storage tank. Then C300 pumping. And then D400. And these are the names of those. And these are the limitations of each isolatable section from and to. And this isolatable section, basically a number which is assigned in the QRA model. Here, if we have marked those basically isolatable sections on the basically schematic diagram of the PNID of this particular facility, 1, 2, 3, 4, 5. These are the 5 isolatable sections on the physical side. Then there were basically parts count, methodology, and leak size distribution. 1 of 2 and 2, the 2 slides are there. So here, just a minute. If I move up, okay, now. Right. So here, if you see that, like a boundary description, isolatable section, phalanges, 2 to 6 inch, and a manual valve, 2 to 6 inch, then instrument connections, then pressure vessel with connection 50 to 100 mm dia, then with connection greater than 150 mm dia, centrifugal pump with connection, then piping length. So in this way, all the basically isolatable section and their parts are identified. Then the following leak size shall be considered for further modeling and assessment as per the OGP and TNO standard. So 1 to 10 mm hole size for small leakages, 10 to 50 mm hole size for the medium leaks, 50 to 150 mm hole size for the large leaks, 150 mm hole size for very large leaks, and piping size leak for full bore rupture. Here, the input sheet and source term modeling inventory calculations, like these are the basically all those 5 isolatable sections. Then composition 70% propane, 30% butane, temperature operating, pressure operating, density, length, then flow rate in terms of basically dynamic flow rate is this, which is given kg per second. Then static mass inventory shall be calculated as per each isolatable section equipment volume multiplied with the density of the service material. For the dynamic inventory calculation, below time factors shall be multiplied with the discharge rate, each isolatable section leak size. For example, automated ESD valve 2 minutes, remotely operated valve 10 minutes. The total mass inventory is equal to static inventory plus discharge rate multiplied by detection and isolation time of the valve. Then the static and dynamic inventory shall be calculated to identify and assess the physical effects from all the isolatable sections with different leak sizes. As per TNO purple book, the following leak size shall be used for dynamic inventory calculations: small 5 mm, medium 25 mm, and large 100 mm. And in this way, if you see here, sectionalizing the same sections, total static volume include 20% additional volume as well, density and total static inventory in kg. Then we got the release rate, then dynamic inventory in kg based on the hole sizes, and total release inventory like a sum of both dynamic as well as the static one. Then once inventory is calculated, we go to calculation of failure frequency analysis. The frequencies of loss of containment from each leak source shall be taken from validated industry databases and combined with the parts count to generate failure frequency of leaks from each section. Then Parts count methodology shall be adopted in compliance with equipment failure frequency databases as prescribed in IOGP 431-01 or 04 standards. The failure frequency of each isolatable section shall be calculated as below. For example, total failure frequency of one isolatable section is the count type equipment multiplied by the probability of failure plus count type of equipment and other multiply of the POF this way. And it continued for all the parts. Then here, if you see this, the example of failure frequency, isolatable section, small, calculated at 2.9 into 10 raised to the power minus 4, and then medium 10 raised to the power 1.1 into 10 raised to the power minus 4, then large into 4.8 to 4.8 10 raised to the power minus 6, then FBR means 0.000 is taken. So FBR failure frequency is not used here. Then from the QRA modeling, following results will be extracted from FAST software, Jetfire, Flashfire, Vapor Cloud Explosion, multi-energy, and then vulnerability assessment for human, plants, and structure shall be defined from OGP 434-14/15 standards. From QRA modeling, following result will be extracted in SPETI software, from SPETI software, location-specific individual risk, LSIR. LSIR is a location-specific individual risk, land use planning criteria, then individual risk per annum, IRPA, risk tolerability criteria, then societal risk FN curve outside the boundary of project societal criteria. Now here, this is the tolerable alarm demonstration. For example, any activity coming in the red zone where maximum tolerable limit is 1 in 10,000 per year, 1 in 10,000 per year. Then there is another number, 1 in 1 million per year, right? Here, if anything which is within 1 in 50,000 per year or 1 in 5,000 per year, that is called alarm, and facilities can be operated this one. But if anything which is coming 1 in 1,000 per year is not acceptable, but 1 in 1,000 per year is acceptable, which is called below alarm acceptable region. This is acceptable. This is as low as reasonably practicable. So here, high risk ranking must be reduced up to alarm level. Then by adding more mitigative measures, then medium risk ranking, alarm demonstration is required and sensitivity case can be introduced. Then low risk ranking, tolerable risk, no further risk reduction measurable measures are required. So normally, ideally here, and if we can get low risk by virtue of the inherent safe design, that it can be considered as acceptable region as well. Now, this FN curve, for example, acceptable risk, alarm, and unacceptable. So these are the number of fatalities, this is the frequency, and here we can accept that if any frequency which is below is a 10 raised to the power minus 7, 10 raised to the power minus 8, and between -4 to -6, which is called alarm. If anything above -4 to -3 or -2, which is unacceptable. Criteria point of view, plant, process plant, and utility industrial facilities are permitted, in general, allowable land use. Then inner zone, development adjacent to the plant with occasional occupancy such as pump house, transformer station, other individual development will be assessed in a case-to-case basis. Non-industrial activities, etc., where the acceptance criteria should be greater than 10 raised to the power minus 5, 10 raised to the power minus 6, 10 raised to the power minus 7, and -7 as well. Here, workplace development such as workers' accommodation, the risk criteria 10 raised to the power minus 6. Residential development public up to 25%, -7. Residential development school and hospitals greater than -7. 10 raised to the power minus 7. Here, when we make the risk tolerability criteria, the outer zone, middle zone, and inner zone of the plant, this is a plant, and this is a residential area around the plant. Here, assumption register, hazards identification done, isolated section markup methodology prepared, process parameters established, provided by heat and material balance as well, inventory assessment calculation method, release direction and height of the storage vessel, human vulnerability, plant and structural vulnerability, then ignition probability with UQA correlation model, risk ranking points, manning distribution philosophy, detection and isolation philosophy, then regulatory risk tolerability criteria. So these are the 12 assumption register items covered. Then QRA modeling input. Here, uploading of raster image of the project specific layout of the facility and surrounding area, define process material as per material composition of heat and material balance sheet for all the isolatable sections, place marking of isolatable section in accordance with plant layout locations and activation of the fast specific model as per type of equipment or type of building. Update weather parameter as per actual site condition. Define the risk marking and measuring reporting point on facility layout raster image. Marking of buildings and other key installation around the facility along with population density areas data. Define risk effects levels in accordance with applicable risk impact criteria. Marking of potential explosion site PES on facility layout drawing raster image as per TNO games method or TNO color book methodology for congestion modeling, not applied for this facility because congestion was not applicable. Insertion of project-specific ignition sources on the layout drawing, raster image, other model optimization actions as needed. So these are 11 actions when you try to make the model in fast and safety software. Here, this is the screen software like overview, like if we're starting a safety demo, then like how it looks like, the route, risk transacts, then population, boundaries, and so and so. Here, like when we are bringing the raster image, so we can see this is the plant, where the plant was located. And here, algebra raster image, SNG plant, then LPG gas, and their composition is shown, propane 0.7%, butane 30%, or 0.7 or 3.3. Then this is one of the isolatable section placement, like first how those are marked on the particular area, filling line, 5 mm leak, 25 mm leak, 100 mm leak, and other like LPG tank, LPG2 pumps, and so there are 5 like isolatable sections which are marked on the plant. So here, physical properties input for LPG, like their parameters like temperature, pressure, vapors. Then here, ingestion of ignition sources, like if they are loading truck, light pole 1, light pole 2, or any other ignition source which can ignite, those are identified. Here, the marking of risk ranking points, like risk ranking points mean risk ranking point 1, 2, 3, 4, 8, or 11, which are marked all over the facilities there. If you have to see on the layout, these are the basically receptors points, blue point, which are marked, and here is the plant location. Then define consequence impact criteria. So here, overpressure effects, then jet fire radiation, and pool fire radiation, and fireball radiation. So these are the basically consequence impact criteria is defined along with. Then final modeling template, like here, all the isolatable sections and where the complete data is populated. So QRA modeling output, we have done the complete modeling, but step by step. But if we use the safety operating manual and some guidance available, some senior available who have used this modeling software earlier, so he can guide you and you can use it. So QRA modeling output mean the worst, like a case of jet fire scenario is found to be due to leakage of 100 mm from isolatable section IS03, causing jet fire with flame length 37.53 meter and its heat radiation of 4 kilowatt per meter square, reaching up to distance of 68.96 meter. The worst case of flash fire scenario is found to be due to leakage of 100 mm from isolatable section IS03, causing flash fire with LFL 42.10 meters. The worst case of blast overpressure explosion due to delayed ignition is found to be due to leakage 100 mm from isolatable section, again IS03, causing overpressure waves of value 0.3 bar, 0.1 bar, and 0.01 bar up to distance of 101 meters, 115 meters, and 288 meters respectively. The location-specific individual risk LSIR value of SNG plant, significant section of SNG plant 8.83 into 10 raised to minus 4. SNG plant is unmanned facility. Then individual risk per annum, IRPA value, potential loss of life values are found to be in acceptable region as 8.84 into 10 raised to minus 6. Societal risk for nearest villa and SNG plant located as code 139, code 313, and code 314 is under acceptable region as well. Now, worst case jet fire contours, which are shown here, the various categories are here, we can demonstrate. Then worst case flash fire scenarios also shown by the software on the contours. Then worst case overpressure contours. Then QRA result summary tabulated form is there, like jet fire thermal radiation distances coming here for each isolatable section, whether 5 mm hole, 25 mm hole, or 100 mm hole. Similarly, for like SNG facility LPG tank 2, there is also weather distance and distance downwind to LFL fraction. So here the weather related, like various winds directions and weather conditions which are considered, and overpressure situation is reflected. So location specific individual risk land use planning criteria. So this was the basically contours. And this one is a FN curve for the societal risk, which things were mainly in the green zone here in the acceptable side, or some area was going into the alarm region. So individual risk per annum and potential loss of life calculations here, the position like operator 1, technician 1, and the probability of each location SNG plant is 2%, 2%, occupancy factor 0.005, and then IRPA 10 raised per minus 6. Total is also 10 raised per minus 6, where PLL, potential loss of life, is 10 raised per minus 6, right, which is acceptable. So here, the most of the plant is shown, IRPA results are in the acceptable range, mostly, and except one minor portion was there. So then, like a final report, what we delivered, this is the basically QRA report, what we have delivered, like a QRA methodology, data source and assumptions, hazards identification, failure frequency analysis, consequences analysis, risk analysis, and all the data conclusion recommendations, SNG plant layout, assumption register, isolatable marked PNIDs, consequence results, inventory analysis results, and so on. So this concludes our presentation. Now we go back to the question answer as a last session, or last part of our session. And I hope like the presentation what we made, it may not make you expert for QRA, but it can give you idea how the QRA is done. And as per my own experience, if there's one person who have done QRA in past, he can train newcomers very fast. It is like a specific steps are there, and specific step if you follow by taking the help from the QRA and TNO and the blue books data and ADNOC standards and SFETI software module. So you will be able to do modeling, and it's quite extensive working when it goes to any refinery plants or gas plants where are hundreds of PNIDs are involved. So it's a quite exhaustive work. However, if we start doing one by one, we are able to manage it, and it's not so difficult task to be done. So, Mr. Ali Ahmed, other question, please, up to you.
Sir, the question is from Mr. Hamid Javed. We have allowed you to speak. Kindly unmute yourself and ask your question. Please unmute yourself. Mohammed Hamid Javed.
Hi, sir.
Yes, please go ahead with your question.
Sir, I have a question. If any incident happen in after the project completion, so who is the responsible, and what we steps are required to follow of the to save the environment or save the people or save the workers?
See here, for example, if you go apply the same concept on the road safety, if the car is tested fit to drive on the road. Number two, if driver is also trained and he got the valid driving license, and then still if accident happens, right, who is responsible? There are the circumstances, for example, some other driver is making mistake, or our driver is sleepy, or exceeding the speed, or not taking the precautionary interdistances. So same is the case here. Plants are designed, built in accordance with international standards. The operators are given training, they are trained, but still, if the operators are not following the instructions and they are bypassing the operating limits, or they're not taking the required corrective actions, so the plant operating team is normally responsible if accidents are still happening and if they are unable to keep the situation under controlled situation. So the answer is because running plants there's a varying situation minute to minute or second to second, and there are basically layer of protections applied, like inherent safe design is there, BPCS is there, ESD system is also there, then PSVs are there, bund wall are there, then emergency response plan is there. So if you take care of all those layer of protection, which are almost 9 layer of protections applied for the safe operation of the plant, so plant would remain safe and we can avoid the accidents. So it's a combination of the inherent safe design, then construction, operation, and then operating staff, operating manuals, and then leadership, the KPIs, the performance standards, proper inspection routine to be followed, proper maintenance to be done, wherever some repair replacement required, that is done. In that scenario, by applying all these mechanisms, we can keep a plant under acceptable risk limits. Thank you.
Okay, sir. Thank you.
So the next question is from Mr. Zain Iqbal. I guess he left.
Okay. How can a fresh mechanical engineer can get involved in QRA project at Velosi? So we are adding many fresh engineers, and Velosi is one of the major contributor of the new trained QRA professionals in the industry, because I believe that we can train fresh engineer in a faster way, and after 3 months, any fresh engineer would be able to do like isolatable section marking, the counting of the parts, and then inventory calculations. And input data point of view, it could be a good source to work under the leadership of the senior engineers. So we have basically a practice of adding young engineers under the leadership of the senior engineers, and the combination of young and seniors are working on day-to-day basis and executing and delivering many projects. So it's like a fresh engineer can join QRA, no problem. Next question.
Sir, next question is from Mr. Vishan Ali. I guess you are unmuted. Please ask your question.
Yeah, Assalamu alaikum, Mr. Ijaz. Good afternoon.
Welcome.
Yeah. Can we mitigate in a hazard assessment and mitigation process? Can we mitigate both of the probability and consequences? And my next question, also very short question. When we mitigate a risk, like a risk is very, very high, and we are going to mitigate, if still the residual risk we get, it is not within a lot, like it is still high. So what action we have to do? And my third question, in your SNG plant layout, one of the part was ESD valve, which must be closed within 2 minutes. So as per API RP14C and API 521 ESD release system, the ESD valve must be closed within 45 seconds. So these three questions, please kindly answer it.
See, when the risk is coming on high side, you have to add some mitigation layers. For example, let's say fire and gas detection system, fire fighting system, or passive fire protection system. These are three things which can help you to basically bring the risk on the lower side, because it can minimize the probability of failure. And other area, for example, if your substation is coming under the consequence area or the contour area, then you have to move it out. That can reduce the risk. So there are certain actions what you need to do before the risk could be brought on the lower side, or you may have to reduce the inventory size by adding one more ESD valve in between. So that could be another area. So this is the first two answers, like if risk is coming on higher side, how to bring it into a lower region. So there are corrective actions, mitigative actions, which could be added and risk could be brought down. Your last question was related to, like, yes, normally BDV valve and ESD valve, the closing time varies from 15 seconds to 45 seconds. However, ADNOC standard, as I remember, they take the time of 2 minutes. So now whether we have to take 45 seconds or 2 minutes for the closing time to calculate the inventory volume, it varies from company to company. For ADNOC, it is 2 minutes, but for other companies, it could be lower as well. It would be decided by the company.
Sir, my second question was, can we mitigate both of the consequences and probability in initial risk?
See, at risk assessment, the consequence side, like if the inventory size is bigger, by adding one more ESD valve in between, if it is possible, right, you can reduce the inventory size. So this is one thing. Or by adding BDV, for example, let's say PSV is there, but BDV is not there, flow down valve, which could be activated along with the ESD system. That can also help to reduce the consequences. When it comes to the likelihood side, right? So like mitigation also on the consequence reduction. For example, if you are adding pacifier protection, it will minimize the consequences. Whereas reduction in the probability is more inherent safe design, or the more reliable system that will try to bring the probability, because in the consequence modeling as such, in RBI, probability is focused, if you can recall, if you're from the RBI and both QRA side. In RBI, we focus to minimize the consequence, like a probability mostly, because consequences, plant is already built and you cannot change much. Whereas probability side, by injecting chemicals, by selecting better inspection techniques, where you would be able to predict any kind of failure before time, that can help you to minimize the probability of failure. Whereas consequences are mostly focused under new projects, and where the consequence could be minimized by modifying the hardware of the facilities. Okay, sir. Thank you, sir. Any other question, please?
Sir, the next question is from Mr. Venkatish Ganapati. We have allowed you to speak. Kindly unmute yourself and ask a question. Mr. Venkatish Ganapati.
Question, Kelly. See, QRA can be done with API 581 data. Yes, QRA can be done by using API 581 data, but API 581 data, like they are using lookup table from the QRA. I know that the software E2G, RBI software, where their QRA modeling or consequence modeling is based on fast models, and those were built by using their lookup tables. So answer is yes, 581 data can be used for QRA modeling. Right. Next question, please.
Next question is from Mr. Unikanan Divakaran. We have allowed you to speak. Kindly unmute yourself and ask the question.
See, question is why QRA not using in construction? See, QRA is done for the process pollutes. During construction stage, there is no process inside the plant, piping or vessels. That's why QRA for construction stage is not applicable. Okay, next question.
The next question is from Mr. Rehan Mahmood. Please ask your question and unmute yourself.
See, how ignition probabilities are calculated, that's the question. The ignition probabilities are calculated based on like the number of leak points and availability of hazard area classification, and if any source of ignition nearby, lightning protection, and so on. So there are various factors which are used to calculate the ignition probabilities as per the Safety software. So these calculations are done by the software directly. We only provide the input conditions. Next question.
Okay. Next question is from Mr. Rohit Kumar. Please ask your question and unmute yourself, please. Rohit Kumar.
Yes, sir. Actually, yeah, I want to know the difference between this RBI and QRA, sir.
Yeah, as I said earlier, RBI is risk-based inspection program. In RBI, more focus is on probability of failure calculations. If we take quantitative RBI, so the more focus would be on like a damage mechanism, their growth rate, their damage factor, cracking factor, thinning factors, and CUI factors. And then consequence side, there are the quantitative calculations also available in the quantitative RBI software. But the calculation on the RBI consequence are more coarse calculations and probability of failure more vigorous calculations. Whereas under QRA, the probability calculations are very simple, whereas the QRA mean consequences calculations are more robust, and that is the difference. RBI more focus on probability of failure, whereas QRA more focus on the consequence of failure. And both are, if we take quantitative technique, and that's the basic difference. Any other question we can conclude the day?
Yeah, okay, sir. Basically, this RBI is like totally based upon damage.
Yes. Like, see, in QRA, we take that like quarter-inch hole, 5 mm hole, 10 mm hole, 1-inch hole, which already assumed in the beginning. Whereas in RBI, we take the like thinning rate, damage, cracking damage mechanism, corrosion under insulation, or fatigue, and that would be causing the some sort of damage, and then the hole size would also be selected on the same grounds, and then consequence of calculation would be made. So the QRA model are more robust with reference to the dispersion modeling, fire and explosion modeling, whereas RBI side, you will find models having more debate on the corrosion rate calculation, then probability calculation, likelihood calculation, then consequence also done up to a certain extent, but the focus on consequence is far lesser in RBI as compared to the QRA calculations. That's the only difference between both. Okay, sir.
Hello, good evening, sir.
Yes, sir.
Yeah, hi. It's a nice presentation, by the way. It's very interesting and highlighting the knowledge of risk assessments. Just one quick question. While we are performing risk assessments, what is the most important to consider, whether likelihood or consequences on the risk rating basis?
Basically, both are important. Both are important because the risk is a multiple of probability of failure or likelihood of failure into consequence of failure. So the more accurate risk assessment would be done if likelihood is calculated on the proper grounds, and similarly consequences of the failure also calculated on the good grounds. So it is equally dependent on both. Okay, sir.
Okay. Thank you. Thank you so much, sir.
So next question is from Amul Pandit. We have allowed you to speak. Kindly unmute yourself and ask your question. Amul Pandit.
See, I can read that, Amul Pandit, like how does the accuracy and reliability of input data, such as the failure rates, consequence modeling, and human error, affect the outcome of QRA, and what measure can be taken to ensure that the uncertainties associated with these data are adequately accounted for and communicated to the stakeholders? See, any risk assessment part or any software assessment when it is being done, so the normal saying is garbage in, garbage out. Right? If we have a trained team, proper data, proper input, then there would be proper output. So whether data is not accurate or whether team is not trained and whether the use of the software is not effective, the results of the risk assessment exercise would also be on the vague form. So the answer is accurate input, work done to be done by the trained team under supervision with proper check and balance, and then use of the proper softwares, and then presentation of those results by the trained team with the due involvement of both consultant engineers and client engineers, then you will be able to have a more reliable result.
Thank you, sir. So final question is from Mr. Arindam Baral. We have allowed you to speak. Kindly ask your question.
Thank you for your insightful presentation, and the discussion are very much helpful. My question is this QRA, how frequently should be done, in context of gene.
Sir, here, as per I can guide you with ad hoc practice. So in ad hoc projects, is a mandatory to do QRA for every project which is applicable at feed stage, at EPC stage, and in the operation phase. And in general, the QRA or HACIA, they call it HACIA studies, are required to be repeated once in 5 to 10 years time. 5 to 10 years time. So in general, that way we can say this as per the ad hoc practice. Feed stage, when plant is being designed, then EPC stage, then operation stage, and once plant is in operation, then there is an interval of 5 to 10 years time. Okay, sir.
Thank you, sir.
Thank you. There are questions still pending, but we are ending to the time limit. Thank you very much for your participation. It was overwhelmed participation from all regions, and we had a maximum occupancy as per our Zoom limit today. So thank you very much and for your participation and interest. And we look forward to meeting you over next webinar next month. Thank you.